Hello and welcome to Houston Techfest 2020, the virtual edition. I'm Leroy Vasky and I'll be moderating today's presentation. First, make note of the question mark icon at the upper right of the presentation screen. If you click on that icon, it will open the question and answer feature, which will allow you to send in questions. Please feel free to post anytime during the session. Also, John will pause his presentation a few times and ask specifically for questions, so watch for those. We're excited to let you know that CodeMag is giving everyone a free subscription. The link is posted in the Q&A section. We are proud to present John Cavanaugh Johnson with Improving, who will be sharing real-world functional web development. John, take it away.
Thanks, Leroy. Good morning, everybody. Assuming it's morning where you are, since we're virtual, I can't assume that too much. Just a couple of quick things. The first thing I'm going to do is show you a few slides from the presentation that I'm contractually obligated. No, I'm joking. A few slides that the Improving folks asked me to show everybody. So one of the things that they wanted to share was that we've got some training courses coming up, and you can see the information here. You get $500 off. It's interesting. The virtual training has actually turned out really well, and folks have really enjoyed that. So if you're interested in that, you can try that out. Also, we're hiring. We have a lot of opportunities. Improving is now all across North America, and we have opportunities for either temporarily or permanently remote positions, and you can see those there. And if you haven't heard, we now have 14 offices, including 2 in Mexico and 1 in Canada. So and we have lunch and learns on Fridays at noon Central Time. You can sign up at the link there, and you can go to our YouTube page to find the older ones. There's even one, I think, that I have on there. So there's that. Now I wasn't supposed to go that far. Yeah, I'm already messing up my cool production values. Okay, how's that? So if you've seen my presentations before, you'll notice that I start them out with a couple of quotes. So the first one is from Khalil Gibran, who says, "Say not, I have found the truth, but rather I have found a truth." I think this is really important for developers to understand, because we tend to see things in binary fashion. It's either this or that. But in fact, all the things I'm going to tell you today are simply a truth that I have found in my work over the years. The other thing that is important to remember is that all models are wrong. Some models are useful. Now, when George Bach said this, he was talking about statistical models, but our views of the world, which is what we build. When we build software, we're building a model of some business process or something. They're all wrong, but we'd like them to be useful. And they're wrong in the sense that it's never complete. So with that out of the way, let's get to the main purpose of why we're here today. So I want to talk about functional web development in the real world. And by the real world, I mean, this is stuff you could use, on the job if you're a professional developer. I'm currently working on a project where I'm using some of these, all of these technologies. It's a great environment, but it's not the first one that really comes to mind for folks. If I say web development, most folks are going to, think JavaScript. They might think about some of the Microsoft stack. What you don't usually think about is functional programming in FSHARP. So I think I should say a few words about why I think functional programming is the right solution for developing web applications for business. Because my career, 30 years, I've worked mostly either as a consultant or a software developer for companies building applications to solve real world business needs. And, when people think about functional programming, if they think about it at all, generally they think about, people who are into math and, data science and those sorts of things, which, that's all nice, but that's not where I live. I live in the world of, hey, Improvi's got a client and they've got a problem that, needs solving, and typically software is part of the solution. So if you take a hard look at what business processes really are, if you think about the typical business process, it generally ends up being made up of immutable data, which is sort of fundamental to the notion of functional programming. In addition, functional programming is generally about manipulating the immutable data through a set of functions, that's why they call it functional programming, as you work along. And so I think the mental model you get with functional programming fits the business world much better than object-oriented programming. Now, that's my opinion. I have lots of opinions about things. This one is one that I've developed after doing this for a really long time. And so I think the fact that, the mental model you get from functional programming fits the mental model you need to solve business problems. On top of that, there are functional programming languages and environments that actually work, that you can deliver, working solutions into the real world. That has traditionally been a little bit of an issue with functional programming, but picking the right stack and language for your problem, I think, is important. Which brings me to my next point: is like, why F#? If you know anything about F#, you probably know that it comes from Microsoft, and it's probably not as popular among Microsoft developers as C# or Visual Basic, and all of that is true. I was, in the beginning, 25 to 30 years ago, a Visual Basic programmer. That's how I got my start in software development. I think Visual Basic is a perfectly fine language. I did a lot of things in Visual Basic. I solved a lot of people's business problems in Visual Basic. .NET came out. I did Visual Basic .NET for a little while. Then I went to C#, and C# is an awesome language. And of course, 20 years ago, it became obvious that nobody was going to be able to ignore JavaScript. Now, I have some opinions about JavaScript. I'll share those later. But, I've done my share of JavaScript. Again, honestly, all programming languages have their place. And if that's the one you're comfortable in and you can accomplish your task, I've got no problem with you using your language. I do suggest that folks should learn more than one language and get some experience in more than one programming paradigm. F# was my way into functional programming, partly because it was based off of the .NET stack, which at the time I learned F#, I had more than 10 years of experience on the .NET stack. So that made it a little bit easier, and the nice thing about F#, we're going to talk about Fable in a minute, which compiles F#, it transpiles F# to JavaScript. You can now write an entire application from top to bottom. Well, so you're probably going to end up having to write some SQL if you're writing a business application, but in general, you can write most of your application in F# now. The nice thing about F# is the .NET base class library, which you would think, well, that's not going to help you on, in the browser. But in fact, the Fable folks have ported a good chunk of the base class libraries, to Fable, so you can use a lot of that in the browser. which, this always confuses me in that, JavaScript has been around for a long time, and there's never been a successful attempt to create any sort of standard library or, there's a million different frameworks and there's a bunch of different, libraries and things you could use. Just seems odd that we've never settled on a decent standard library. And one of the things that I really like about FSHARP is it has a nice set of the really essential stuff that a developer needs to write good applications. I write applications for businesses. They don't pay me to re-implement, a quick sort or something like that. That's not what I do. I want to solve problems, and to solve problems, you're going to be depending on libraries and resources from other folks. And the one thing that is awesome about JavaScript is there's more than enough libraries to do almost anything you want. In fact, the biggest problem with JavaScript in my mind is probably that there's too many libraries and too much change. So before I get into the particular topics I want to talk about today, I did want to check to see if there are any questions. So Leroy, do we have any questions teed up yet, or have I just confused everybody?
No, you haven't confused everybody. Actually, you've piqued their interest. So the first question is, what are some of the big differences between C# and F#?
Oh, that's a really good question. Probably something we should spend a little time on. So the first thing you will notice, I mentioned immutable data. Let me explain what I mean by that. Typically in F#, you would not have a variable. You would have a value. And the reason that matters is because in F#, every line of code you write is an expression. It gets evaluated at that time. So if you say, let x equal 5, the F# compiler says, okay, I have bound of a x, that name, to the value of 5 as an integer. Now, if you had said let x equals 5.0, then it would be a float. So that is the first thing. Now, you can use mutable data. Occasionally, you need to do that, and there's ways you could do that. But that's probably the first thing that will get folks. The second thing that I think is a big difference is that F# is a white space sensitive language. And a little bit later on, we'll see a little bit of F# code, and I'll go back over some of the stuff then. But to give people an understanding, so you're going to have the indentation of your code matters. It's not an optional thing. It's not stylistic. It has meaning to the compiler. And we'll see some examples of that later on. That is very, at least for me, when I first started in F#, was very frustrating. It was hard to get used to for a little while, and then you get used to it and it starts to make sense and you get it. The other thing that you'll notice with F# is because it's a descendant of what they called ML languages, which is two people's initials, it's not machine learning, that it actually does a really good job of figuring out what the types for your values are. So I mentioned let x equal 5. The compiler knows right then that x is an integer. And if you pass x to another function, it'll only let you do that if that function accepts an integer. That's, in my mind, really valuable. The other thing that I think is a big difference is that with F# and C#, F#, it's called functional first. You can create objects, but that's not the standard way of doing things in F#. And we will see a few examples of that. Under the covers, they both compile down to IL. Typically in F#, you'll be using things like discriminated unions and records, which we'll look at a little bit later, which are very different from your typical, OO approach to modeling the world. But I think in general, that pretty much sums it up. So that was a long answer to a short question. Do we have any more, Leroy?
Yes, we have one other new one. Let me go ahead and read it, and then I'll publish it across. Are there reasons to use FSHARP and times not to use it?
So that's actually, I think, a pretty good question. So, what language to use in any situation is, I think, a question a lot of people evaluate on, like, what is this language good for? You can do most anything in most any language. You don't necessarily want to. So here's what I would say. The most important thing in choosing a language is knowing the people who are going to be working on the project with you. If you don't have any developers who know FSHARP, you're going to have to spend a little bit of time getting folks up to speed. If you do have developers who know FSHARP, I think in general, for most business-oriented applications, it is my first choice. May not be your first choice, but it's mine. It'll run on any of the major platforms in .NET Core, so you can do it on Mac OS or any of the various Linux site, whatever, and of course Windows. There's some pretty good libraries for building mobile apps with FSHARP, believe it or not. I don't do a lot of mobile apps, but that's something you could look into. I think it's really good for modeling business processes. So, sometimes you might use it on the back end, but use, JavaScript or something on the front end because you've got some front end developers who just know JavaScript. And it is a little hard to make that transition from an untyped language like JavaScript to a very strongly typed language like FSHARP. So in general, I'd say look at what your developers know, look at the kind of application you're going to build, but generally that's not a big deal anymore. And I guess the other thing is you have to look at, okay, do I need some specific library or some third-party tool? There are times when you're going to say, oh, I'm going to have to do this in C++ because that's the only way to be able to use this. Or, oh, I'm going to deploy this on an IoT device, so maybe I'll do Lua or something like that. So, that's how I go around. Like, is FSHARP going to run on your platform? Are you comfortable with the language and functional, strongly typed programming? If so, that's when I would use it. So that's enough questions for now. I want to talk about the particular stack that I think really makes FSHARP viable for real world web development. So, okay, before I go, so I don't know if anybody here is a regular at Techfest, but 3 years ago at Techfest in Houston, I did a presentation about Fable. At the time, it was sort of an experimental thing, and it was like, I can't, tell you should use this in your real job, but this is a cool thing that you should be looking at. Today, 3 years later, I can tell you that, yes, this is something you could use in your real job. You can be productive quickly if you're familiar with FSHARP. But when I was looking through my old slides, I found something, and I'm just going to show this. I was trying to explain how I felt about JavaScript. So I said, there's a Venn diagram between things that are horrifying and things that are adorable. And so this is the Venn diagram that I had 3 years ago. This is it. It's exactly like it was. Those are my two granddaughters, Amara and Lucy, when they were 1. They're 4 now. And the things that I listed for horrifying were preventable pandemics and torture. And I still find those things horrifying. And of course, the only thing that's in the overlap between horrifying and adorable is JavaScript. Now, why do I think that about JavaScript? Well, it is adorable in the sense that, you can, write JavaScript in the browser and it'll run anywhere. And, and it's just kind of horrifying in the way that it's loosely typed, and they're stuck with design decisions that were made by, in the course of a week when somebody designed the language. And, for somebody who prefers strongly typed languages, JavaScript is a bit much. It really, again, JavaScript works great. People have done amazing things with JavaScript. If you're going to write a big application with lots of folks in development, it becomes very unwieldy. I know this from experience. It just does. So let me talk about what I really want to talk about today, which is something called SafeStack. Now, the idea behind SafeStack was that, with Fable and some other, pieces of technology, it really was possible to write real world business applications, but it was very difficult to figure out, well, where do I start and what, how should I make this work? And so some folks from a consultancy in the UK, Compositional IT, decided that, what they really needed to do was put together a .NET template that would pull in the various pieces of technology you need to build a real world application. So it ended up in the original formation. They were using Saturn, which is a web server that we'll talk about in a minute, and Azure as a deployment platform. I assume everybody knows about Azure. Fable, which is the transpiler for FSHARP to JavaScript, and then something called Elmish. So if you're familiar with the Elm programming language, they had a very interesting way of doing web development. And so some folks adapted that to FSHARP and Fable and built a library that sits on top of React, believe it or not, to build web applications. And we're going to drill down into each of these. So Saturn is a web server. It runs on top of an F# application called Giraffe, which runs on top of ASP.NET Core web server, which is sometimes called Kestrel. So if you're a .NET developer, you probably know what Kestrel is. Interestingly enough, the nice thing about that is that you have, excuse me just a minute, I did something terrible, which was forget to turn off my phone. Okay, sorry about disappearing there on you folks. The ASP.NET Core web server is a very performant web server. I think it works in all of the cases that, for all the use cases that I have. I mean, there are some, there are some things you can do where you might want to use something else or write your own web server, although that doesn't sound like fun to me. But, in most cases, it works, really well. The Saturn and Giraffe layer sounds like, oh, that's a lot of layers on top, but actually it has very little impact on performance. You can go look up all the indexes and, that kind of stuff. I think it comes out really well. The nice thing about Saturn is it is specifically designed from a functional view of the world. And so it fits in very well with the F# model, and it hooks up nicely to Fable. So we'll see a little bit about how that all works when we look at the code in a little bit. But in general, what is you're getting a very high quality web server with a functional layer on top that allows you to pipe your handlers from one to the next. It is really a nice experience for writing applications. Azure, I assume most people know what Microsoft Azure is. It's Microsoft Cloud Platform. By the way, there's also support for AWS and Cloud and Google Cloud and whoever, right? I mean, but the default support is for Azure, and I think, for writing business applications, that's a reasonable choice. AWS is a reasonable choice as well. In general, they have some nice integration for deploying stuff to Azure, which I don't know if you've got much experience deploying complex applications to Azure, but it's non-trivial, and they have a setup that makes it pretty close to trivial. I really like the way you can deploy things. I've been doing that in my real world job very frequently, and it's just a very nice experience compared to the other ways I've had for deploying things to Azure. Fable. Now, this is where things get really interesting. Fable is a complicated beast. It effectively takes your FSHARP code, it extracts out the AST, runs it through Fable, which is a transpiler for JavaScript, and it spits out some nice, pretty JavaScript at the end. So it makes it very easy to interoperate with JavaScript libraries. And in fact, there's a lot of libraries which have packages for Fable so that you can use things like React or, whatever, just directly from FSHARP without having to worry about a lot of the ugly differences. Now, sometimes you may want to use a specific FSHARP library, or excuse me, a JavaScript library, and you may have to do a little bit of work, making that transition. But there's some nice documentation on how to do that. I generally have tried to avoid having to do that sometimes, and looks like I'm running into one of those situations in my current engagement where I'm going to have to do sort of create my own mapping. Typically, you do that through TypeScript. If you're familiar with TypeScript, it allows folks to put types onto the untyped language that is JavaScript. So if I have to do JavaScript, I typically will prefer to do TypeScript. Again, that's one of those things. It's because I like strong typing, and because TypeScript is actually really nice about certain kinds of things in terms of creating types. It actually works incredibly well when you need to take in some sort of untyped API in JavaScript and create, a typed layer for FSHARP. For all the big stuff, that's already been done, the browser, React, that sort of thing. Elmish. Elvish is a little hard to explain, and so I'm going to explain that mostly when we're looking at the code. But I will say this, like I said before, it's patterned after Elm. It uses what's called a model view update. You start out with a view, which is your HTML, CSS, user interface kind of thing. You have a model, which in the Elvish world is an FSHARP set of types, or a type, with some types and things. But, you have a model that you describe the business or whatever domain you're working on. And you have messages that is used to tell the view what has changed in the model, and then the view will update. So you're basically working in a message loop, which, again, I think about the way the business world works. Now, I'm guessing that a lot of people listening to me probably aren't old enough to have worked in the business world before computers actually did everything. But I'm that old, so I know how things work. And if you're ever curious to see this in action, oh wait, nowadays you can't just go down to somebody's office. I'll have to start recommending movies you can watch. But anyway, the way a bureaucracy works is pretty straightforward. Imagine, if you can, in the before times, when you could go to the Department of Motor Vehicles, and you would go down, and you had to renew your license, or, get your driver's license. So I have 5 kids, and I took them all, I taught them all how to drive, and I took each of them, for their driving test. So when you do that, you go down and you have some forms that you filled out in advance, right? And you hand them off to somebody, and that person, does their thing, and they hand them off to somebody else who may do their thing. And then you wait for a little while, and then they call your name, and then you go do the test, right? Reasonably familiar to folks, right? So that's the way applications work too, if you think about it. Like, I have a message, right? That's the forms I had to fill out, right? They have types, that's the model, right? You don't just walk in and write things down on a random piece of paper for the Department of Motor Vehicles. You fill out their form. That is their model, right? It's like, this is what we care about. We care about how old you are. We care about whether that kind of thing. So you hand them the message, right? They take that message, they go do something with it, right? There's some process that processes that message. Eventually, that makes a change, right? You're sitting out there waiting with, all the other people who are waiting to take their driver's test. And eventually you get called, right? There's a message that comes back. And guess what? It's asynchronous, right? Unless you're very, very lucky, you never went in and got your driver's test, right when you walked in. And usually you have to wait, right? So the real world is really a bunch of messages and events and asynchronous communication. And really and truly, all businesses work that way. And so it works out really well to model it that way. At least it has worked out well for me. Now, I do want to talk about one piece that's not, a big part of it, but I think actually for me, the thing that makes this work is a tool called Fable Remote. It's very simple. It does this thing. And what it does is, like, you got to find your types in FSHARP. And you share them between the client and the server. Because you're running them both in FSHARP, that's fine. You can do that. So what you're going to do is you're going to define your types that model, whatever it is. You may have payment types if you're writing an e-commerce site, whatever, right? Fable lets you send asynchronous messages from the client to the server, and you don't have to mess with any of the plumbing. Like, they get serialized, they get deserialized on the, and the response goes back. Your only limitations are you have to define your APIs as functions that take FSHARP types that are in your shared space, which is the way I've always wanted to do applications. I mean, for me, the idea of, okay, here's these things that my application cares about, the things internal to my application. And, there's none of this nonsense with, DTOs and, let's convert this to JavaScript. I mean, that all happens, but because FSHARP has a good type system, that can all happen without you having to know anything about, what do I use a promise, or do I use Ajax, or look, don't worry about that stuff. Don't worry about the serialization format unless you want to. Typically it'll be JSON, but you can do message pack. It's you just tell it that's what you want to do, and it will do that. And I think those are two very useful serialization formats. One of the things I like best about this whole stack is there's a real commitment to not making things overly complicated, and I'll get into that in just a minute. So before I go any further, because the next step is all you're going to see is a command prompt and some stuff happening for a little while, and then we'll look at Visual Studio Code. So before I get into that, Leroy, do we have any questions?
We have one question. So it is, would you consider Fable and FSHARP to be a viable alternative to something like TypeScript? I primarily work with JavaScript, but I recently started moving more into strongly typed languages, and TypeScript has been my introduction to that. So TypeScript is a great strongly typed language. It really is. I like TypeScript. I mentioned, that I started out as a Visual Basic programmer, so I'm kind of like personal preference only. Like, I prefer not to use the, curly brace and semicolon languages, the C-derived languages, but that's just a preference. TypeScript is great. I don't think there's actually a really great story for TypeScript on the server. I mean, some people are fans of Node.js, but I have some
architectural issues the way it's built, but that's neither here nor there. I think to answer your question is, get comfortable with TypeScript and the kinds of things you can do with records. You can do discriminated unions in TypeScript. And then, yes, that's a perfect lead in to looking at FSHARP and seeing how it's actually a lot simpler, I think, just that's my experience, to do functional, strongly typed languages, a strongly typed language that you can spread across the server and the client. I will say that, all of the magic of Fable is based off of being able to create or consume TypeScript types that people create for various libraries. So we're going to be creating what is under the covers just a React application. But we're not going to really see much of React at all. But that can only happen because people have written the TypeScript types for React. So I think the answer to that question is yes. Took me a long time to say yes, didn't it? Okay, so now I'm gonna switch over to Windows Terminal, and we're gonna create an application. Okay, so I assume that everybody can see my terminal. Does that look big enough to read, Leroy?
Yes, it looks good to me. And nobody has commented that said that they have an issue. I think we've given them enough time, so I say go for it.
Okay, so I'm just gonna move over to my personal directory. Now, the first thing I want to do here, I like to create a directory for my new projects. So I'm good, and I think you could tell I'm in a PowerShell window. So I want to make a directory. We'll call this Techfest 2020. And then the thing that I typically forget to do is change to that, but I'm not going to forget. Now, I'm also going to let's go look at the SafeStack website real quick so we can find the instructions on how to do this. So you should be able to, now you should be able to see my browser window. Everybody see that okay? So what we've got here, this is safe-stack.github.io. That's where you want to go to do some follow-up on this. So we'll make this the quick start because we don't have that much time left for this. And I want to get everybody out of here on time. So we'll go to the quick start. Now, what do you need before you start? Now, I'm going to assume if you're developing web applications, you probably already have this stuff, but you'll need to go install it. You'll need the .NET Core SDK. You'll need Node and NPM. And if you're going to do Azure, you're going to need the Azure CLI. So I have all those things already installed. Also, you'll need a code editor. I strongly recommend that you get Visual Studio Code. It has a great plugin for FSHARP called Iodine. I find it much better to develop applications, especially Fable and SafeStack applications, than using Visual Studio, which I use that a lot too, but I prefer VS Code. There are some folks who love JetBrains Writer. I've not really used it, to be honest with you. Now, you will see that we have some instructions here. I hope, let's see, let's make that a little bit bigger. Okay, so here we go. This is what we're going to do. Right here, we're going to do .NET New, install the save template. So let me, I'll switch back over to terminal. Okay, so here we go. We're going to do a, so that is basically telling .NET to go get a template. And so it does that. And so the next step we're going to want to do is we want to create a new safe project. So that's .NET New Safe. So now we have, so what exactly did that do for us? We created the template. Well, the first thing we need to do is do a .NET tool restore. Now, I want to talk about what happened right there. It restored two tools that are really important. They are very commonly, now, you don't actually have to use these tools to do safe. They have a minimal template where if you prefer to use NuGet instead of Packet, you can do that. But Fake is, it's a make style application. So, everything in FSHARP starts with an F. So, if you've ever used the PowerShell tool Saki, which, or if you've ever used, the C make or whatever, right? It's that kind of thing. It's a scripting language that you can use to build .NET applications, and you can build Fable applications. So I strongly encourage you to get the CLI for Fake and Packet. Packet is an alternative using NuGet. People always ask, well, why does those FSHARP people use Packet? Well, so the big difference is Packet makes a real attempt to make sure that all of your dependencies and their dependencies and all of that stuff actually is, you're using the same versions everywhere, which once you get a lot of dependencies stacked on other dependencies can get really complicated. The two tools together make it very easy to have reproducible builds. I like them both a lot, but again, you can use your own build tool and you can use NuGet to get your packages if you want. Of course, for your JavaScript packages, you'll be using Yard or some NPM or something, right? Okay, so we've restored our tools, right? And so now we want to build this application. And so there's a Fake command line that we're going to use. And these are .NET tools, so you use .NET and you say Fake and you give it the command build and then you give it a target. In this case, the target we want is run. So when we do this, a lot of stuff's going to happen, and it happens slowly enough that I can talk about it while it happens. At least the first time. In the future, it gets, now ignore the things about .NET Core App 5.0. I have a beta version of .NET Core installed, and so you get those weird warnings. But okay, what it really does is, it's getting ready to install the client side of your application. So since this is the first time we've ever done anything with this application, it's got to do all the NPM stuff, which means, okay, we're going to get all the dependencies. Like any other modern JavaScript application, you got a gazillion dependencies. So it found all the NPM stuff, downloaded them, gets everything installed, and then it uses Webpack, the Webpack dev server. If you're a web developer, I assume you've heard of that at least. Fortunately, it configures everything the way you want to, and then you get a little, Windows Defender firewall thing that you have to say, yes, allow this thing access. And so now it's going to go compile the FSHARP side of things. So it pulled out all these JavaScript packages. These are the FSHARP NuGet packages that give you the interface to the JavaScript libraries. And when it's all done, if you don't have any errors, you can go look at your nice little application, which is, let me switch over to my browser again. And we will, if I can find my browser window, there we go. We'll go to localhost 8080. And ta-da, we have a to-do app, which is, that classic useless sort of application that everybody uses for demos. And so, you can add things like make a presentation. Right? And so that's not all that impressive from a visual perspective, but there's actually some really interesting things going on under the covers. And I want to look at that before, we run out of time. So I'm going to switch over to VS Code. And I am going to go open up that, oops, that's the wrong location. There we go. And I want to open a folder, and I want to go up because I put this guy. Where did I put that guy? Oh yeah, this guy. That's the folder I want. Now, some interesting things actually happen here. Because I have Iodine installed, it's going to figure out that this is a Fable FSHARP application. And so you probably don't normally see this if you don't do FSHARP, but you get this nice little tool over here. And it shows you this thing now. It's loading the project, so we'll let it. Now, one of the nice things is the default install now comes with test projects. So, I know Claudio's going to love that. Inside joke for improving folks. But anyway, so the nice thing about this is that, and let me go down here and let's take a look at the client. Well, now let's take a look at the server first, actually. So, that's not what I wanted to do at all. Let's look at server.fs. I don't know what that is. Whatever. So I want to walk through this very quickly because we don't have a whole lot of time left, but this is a module in FSHARP. If you're a C# developer, this is the equivalent of a using statement. If you're a JavaScript developer, this is an import. So we're going to use Fable Remote server and Fable Remote giraffe, and then we're going to open Saturn. Remember I mentioned Saturn. So I'm going to ignore this type called storage for a minute because I really want to look at the API. So this is typically how you're going to define an API. Well, this is the implementation of the API. Let's go up here to shared. And so your type to do, that's your business model in this case, this is a record, which says, okay, I have these things. They have a GUID, which I always pronounce good, but if you want to call it good, that's okay with me. And it has a description, which is a string. We have another module called to do, which defines some functions that decides whether or not the description is valid. So in this case, it's real simple. It just checks to see if it's a null or white space, right? It has a create, which gives it a do good. And then we have the route. And this is where you build your routes. Fable and Saturn and .NET Remote have a nice set of defaults that I think are really useful. Basically, you get a type name and a method name to create your route. And then you define an interface, and this is what's really important. You define an interface with your API, which defines, okay, here's a function, here's what that function takes, and here's the async thing that it returns. So this is similar to what you would do with C# with async and await, and in JavaScript, there's 12 different ways to do that, but I think you guys will get the best, the point here. So both the client and the server share this, so they both have an understanding of what the API is. The client, sends things, and this tells them what they're going to get back, right? If we go back over here to the server, right? This is the implementation of that interface, right? Which has get to dos. Oh, by the way, this little bracket thing there, that's what we call unit. That's a nothing. If you're familiar with void, it's sort of like that. But anyway, it calls storage.getToDos, so, you have the nice little, this thing goes to that, right? And add to dos. One of my favorite things about FSHARP is that fun is a keyword. And it says this is a function, which is, which goes to this asynchronous implementation. This is a batch. So it says, okay, the add to do either came back with an okay or an error, and we will return the thing if it came back okay, and we'll return an error if it got an error. So let's go back up here and look at this type, which is, okay, so this is really fascinating. If you're familiar with list with a capital L in C#, that's called resize array in F#, because list means something completely different in F#, but that's beyond the scope of what we're going to talk about right now. But it gives you what C# folks would recognize as a list. And so this is what list is in F#, which is basically a linked list. And it converts it to a sequence, which is basically IEnumerable of to-dos. So it'll send back that, IEnumerable of to-dos. And if this is sort of the object world here in F#. It has a member. It says add to do. It takes in a to do, which is strongly typed, and if it's valid, it adds it. Otherwise, it sends back an error. So if you try to send in a blank to do, it will send you back an error. Pretty straightforward. Now let's look at the client. So this is where things get really, really weird. I'm going to go through this pretty quickly because I want to leave a little bit of time for questions at the end. So this is my model. Here's my messages. These are a discriminated union. So I can get any of these kind of messages, but if I get a message, it's guaranteed to be one of those. Here's the implementation of the API, which is I call the remoting, create the API, and I give it the route. I get the route back from it, and it builds me a proxy for that. This is the initialization function, and this is what you see in Elmish. You get a model and a command, which has a message inside of it. And so when we get a message, we run update, we take the message and the current model, and we match the message with, you remember these alternatives up here, and depending on what it is, we go do things, right? It says, okay, if you get this message, if it's a get, then you take the to-dos that it passed you, you add those, you take your model and you swap out the to-dos that already exist with the ones that got sent in, and you say, okay, this is a command of none because there's nothing we're going to do. If it's a set input, you're going to do a similar kind of thing, right? So this is how you process messages. And so here's our actual application and the view. So we create React elements, got this little sort of stuff here. Like, if I had more time, I'd describe how this is a DSL for creating HTML, which is really handy. But we'll leave that aside for a moment, just so you know, what you get is the thing, and we'll go back and look at this in a minute. Here's our view, which takes a model, it dispatches a message, right? So every time you process one of those messages, it comes into the view, right? And it goes through and does whatever update it needs to do based off of the model, the message that you got. And if you look inside this app, this is all really simple. This is how you build your application. And all this really says is, okay, hook all this stuff up for me, right? Just hook all the stuff under the covers that hooks up the Elvish model view update to all the React infrastructure underneath, so that I can build my app out of this thing here. Now, let's switch back over real quick. Yes, to our browser. Now, Wait, that's not showing the browser, that's showing VS Code. Hold on a second. Make VS Code go away and make the browser. Okay, there we go. Now, to connect the code up with what you see, when I type something here, when I hit add, it calls a remote API. The server does its thing. It returns back the call. It gets converted into a message. It gets processed, and the view gets updated. Oh, that's a terrible. Let's see. Check my text messages. Right. So what all happens under the cover is just a bunch of message passing, and the UI knows how to interpret the message so that it sends that thing off to the server validates it, it comes back. Now, that's not terribly useful, but from those simple tools, you can build interesting real-world business applications with all the nice little, things that you're used to having in a decent environment. So, almost out of time. Do we have any questions, Leroy, that I have time to answer?
You have time to answer all of the questions that are currently available because you've done a great job. Everybody's connected. There are no new questions.
Oh, well, excellent. Well, I just wanted to tell everyone, thank you for listening to this. I am very excited about this technology, and I realize that we just, skimmed through this at a pretty high level today. So, I will make sure that there is an opportunity for folks who are members of various user groups in town to learn some more in depth. So thank you very much. And I really enjoyed and have a great rest of your day. And there's tons of interesting things going on at Houston Techfest. So be sure to check those out. Thank you.
Yep, and let me echo that. Thank you everyone for attending today's session. And John, special thanks to you for sharing this.